Hello, and welcome to our first lesson of Chapter 4, which is our first of 3 trigonometry chapters. In this chapter, we will be looking at a unit of measurement called radians, and we will be looking at our standard position angles, reference angles, something called a coterminal angle, and how to solve some basic equations. So in trigonometry, we usually use degrees to measure angles in triangles. However, a degree is not user-friendly in many situations. So we actually have another unit of measure to measure angles. So similarly to how we can convert between an inch and a centimeter and use those both to measure distances, we can use radians and degrees to measure angles. So our better way that we are going to be looking at is radians. So we think about something called a unit circle. A unit circle is simply a circle with a radius of 1, or r equals 1, and a circumference of 2 pi. Now, the reason the circumference here would be 2 pi is because we know circumference of a circle is 2 pi r. And in this case, with a unit circle, our radius is 1. So 2 pi times 1 would simply give us 2 pi. Now, there is a relationship between the angle and its circumference. Normally, we would have 360 degrees in a circle. And if we look at this specific circle with a radius of 1, we know our circumference is 2 pi. So if I look at, for example, an angle in the middle of the circle, theta, this angle here would be a certain chunk of our circle. Maybe it's 2/3 of our circle, maybe that is 2/5 of our circle, however much we decide, whatever big chunk we want to take out of our circle there. And the distance around the outside of the circle, the circumference of that chunk there, would be proportional to the entire circumference, with the same ratio that that angle is proportional to the entire inside angle of our circle, 360 degrees. So in this case, this is a radius of 1. And that little sign theta, this just represents an angle. We say this is theta, and this just represents an angle. So now instead of using the angle 360 degrees, we're going to use a unit of 2 pi, which are called radians. So 2 pi radians can now be used to describe the angle 360 degrees. And how that came about is by looking at the circumference of a circle of radius 1. So basically, when you travel along 1 radian, okay, that's going to be a specific distance along the outside of our circle. With a half circle, our angle would be 180 degrees. This here is 180 degrees. Okay. And this would be a half of our circumference, which instead of being 2 pi would be 1 pi. If we went around the outside of that circle, that would have a circumference of pi. So this means that 180 degrees is equal to pi radians. And this is what we are going to use to convert between degrees and radians. So a portion of a circumference has a specific name. So in this case, we had a half circle, and the circumference therefore would be around the outside of half of our circle. In the previous example there, you see that red outer portion, this portion right here, that would be called an arc length. So arc length is used to describe just a portion of the circumference. So to calculate the arc length of a circle or the distance around the outside of part of a circle, we need to convert between degrees and radians using our conversion factor. So our conversion factor is just the fact that 180 degrees is equal to pi radians. Okay. So if you have ever done conversions before, you know that when you convert, you're usually going to make a fraction out of your conversion factor. You put what you want on the top, and the units you already have go on the bottom. So our first question here, we are asked to convert 40 degrees into radians. So I already have degrees and I want radians. So this means I'm going to take my 40 degrees and I'm going to multiply it by a conversion factor turned into a fraction. My 180 degrees is going on the bottom because the degrees are the units I already have. And my pi radians are going to go on the top because radians are the units I want. Okay. Then when I multiply this, I get 40 pi on the top and 180 on the bottom. Now, the units of degrees with the 40 and the 180 cancel out, which means my units now on the top would be radians. And I can simplify this fraction to be 4 pi out of 18 if I divide them both by 10, which then also would give me 2 pi over 9 if I divide both those by 2 radians. So this means that 40 degrees is equal to 2 pi over 9 radians. If I think about this, 2 pi was an entire outside of my circle, similar to my 360 degrees. 2 pi over 9, that means is 1/9 of my circle. And if I think about that, 40 degrees out of 360 degrees is also 1/9 of my circle. We're also going to look at what if we have to go the other way? What if I wanted to go 1 radian into degrees? So I'm going to take the unit they give us, which is 1 radian, and I need to multiply by my conversion factor. My conversion factor, I would be putting my 180 degrees on the top because the units I want to change to are degrees. And I would put my pi radians on the bottom because the units I already have are radians. So the units I want go on the top, the units I have go on the bottom. Now this means that my radian units will cancel out. And I end up with 180 over pi degrees. My 0 there looks a little small. Let's fix that. And if I actually, let's put that in brackets to be a little bit more clear. That's 180 over pi. That's my number. And my units are degrees. If I actually divide 180 by pi, I get 57.3 degrees. So 1 radian is approximately 57.3 degrees. So for our conversions, in this box, I'm just going to put a little note about conversions. If I want to go from degrees to radians, I need to multiply by pi over 180. If I want to go from radians to degrees, I'm going to multiply by 180 over pi. So just a note, when you're dealing with radians, you could write the word rad instead of radians on your calculator. That's what the short term is, or they just use an R. Okay. Now, often you will see when we're talking about angles, they actually won't write anything if you're using radians. You'll always see that little circle for degrees if we're talking about degrees, but for radians, most of the time, like in a textbook, it's not going to say the word radians. It'll just say theta equals 2 pi over 9. It won't say theta equals 2 pi over 9 radians. So just be very careful when you're reading a question. If you see that little circle, that's for sure degrees. There's no units, then you are assuming that that angle is in radians. So now I've got a little, not a typo, but I'm missing my units here in my Word document that I'm writing on. So this here, this little question mark should be a pi. So it's asking us to express the central angle of a quarter of a circle in radians. So first, if we have a central angle, just a reminder that that means that's the angle measured in the center of your circle. So that would be this angle here. And it's of a quarter of a circle. So first, a quarter of a circle we know is 90 degrees. And so we want to know what is that in terms of pi. So we can do a conversion here if we want. We could do 90 degrees times pi over 180, which would give us 90 pi over 180. And if I simplify that, this gives me pi over 2 radians. But I also know that 180 degrees is equal to pi radians. And a central angle of a quarter circle is 90 degrees. That's half of 180. So this means that my radians must also be half. Half of pi would be pi over 2. So we can do the full conversion route where our degrees cancel out, we simplify, and there we go. But we can also just use a bit of common sense. We know that 180 degrees is pi radians. Half of that would be pi over 2. We're going to use these radians to help us calculate some arc lengths. So with an arc length, this is just the distance around the outside of the circle. And it should be fairly intuitive that if I decrease the central angle, so my theta in the middle gets smaller, we can see that the corresponding circumference on the outside, that arc length, should also get smaller. So our first picture on the left here, our theta is bigger and our arc length is bigger. And the picture on the right, our theta is smaller, our arc length is smaller. This should make sense. And these change proportional to one another. Okay, so the ratio between the arc length and the circumference should equal the ratio of the angle at the center to the total angle. Now we're going to use pi and radians for this. So you'll see that my angle at the center here is 2 pi. So, or for a whole circle. So a whole circle has 2 pi radians, right? And the circumference of a whole circle. So this would be for a whole circle. So the arc length of our portion over the circumference of the whole circle would be our ratio. And that should be equal to the ratio of the angle at the center of our portion to the angle at the center of a whole circle, which in radians is 2 pi. So I'm going to call arc length A. So this is our arc length. We know the circumference of a circle is 2 pi r. The angle at the center we're going to call theta. And in radians, we know the angle at the center would be 2 pi. Now, this means if I simplify this, if I want to find out my arc length, I can multiply both sides of the equation by 2 pi r. My 2 pi r's on the left would cancel out, and I would be left with just arc length. And on the right, the 2 pi that I multiplied by would cancel out with the 2 pi on the bottom, and I would be left with r times theta. Okay. Theta needs to be in radians, and r is our radius. So I can find the arc length of a circle if I take the radius and I multiply it by the corresponding central angle for that arc length. The corresponding angle must be in radians for this equation to work. If we changed this 2 pi up here to 360 degrees, what would happen is when we get to this step, the 2 pi's would not cancel out because we wouldn't have a 2 pi on the bottom. So our formula would end up being a bit different. It would be similar, but a lot messier. Okay. So for us, if we're using this nice simple A equals theta times R formula, our theta needs to be in radians. Okay. So we're going to try a couple of these. So given our unknown here, we want to find theta. A is 28 and R is 5. So we know A equals theta times R, or R times theta. It doesn't actually matter which order you go in. Okay. A is 28, theta we don't know, and R is 5. So now we can divide both sides by 5. And we get 28 over 5 equals theta, or we can actually plug this into our calculator and get 5.6 radians is equal to theta. Remember, our theta is always in radians with this equation. Okay. We don't have to write the word radians here. We could write the word rad, or we could just leave it out altogether and just say theta is equal to 5.6. Let's try the next one. So we know that A is equal to theta times R, but theta should be in radians. So we must change this to radians. So we've got 120 degrees times our conversion factor. We would be using pi over 180. This would give us 120 pi over 180. Our degrees cancel out. This would be in radians. If I simplify this, I get 12 pi over 18, or 2 pi over 3. So our theta is equal to 2 pi over 3. Now I can go back to my question. A is equal to 2 pi over 3 is our theta times 15 is our R. This gives us 30 pi over 3, or 10 pi. And we have units for this question. If our R is in centimeters, our circumference would be in centimeters, which means our portion of our circumference, that arc length, would be in centimeters. We usually just leave the pi there. Okay? Technically, you could actually multiply 10 by pi and find out a number with decimals and such, but usually it's considered a neater answer to leave the pi in our answer. If you'd like to, you could pause here and try the next two on your own and then come back and look at the answers. That might be helpful if you're finding this easy. If you're finding this a little bit more difficult, you can continue to follow along. Our next one, we have A equals theta times R. A is 3.6. Theta is 1.57. Notice how there are no units at the end here. There's no little degree sign. That means this is in radians. And this is times R. I want to find R, so I'm going to divide both sides by 1.57. And this is going to give me 2.3. And we can see our arc length has a unit of m, meters. So that means our R is also in meters. We should get r is 2.3 meters for that one. And last one, a is equal to theta times r. We don't know a, that's what we're trying to find. Theta is pi over 3. R is pi. This is going to give me pi squared over 3. And again, we would usually just leave our answer like this, leave the pi in our answer. You could, on your calculator, take pi, square it, and divide by 3 and get a decimal answer, but normally we would just leave it here. Now there's some practice questions on the bottom from the Precalculus 12 textbook. You can try those for some more practice. And if you need to, you can go back and watch any portions of this video that you found difficult.